What we're talking about today is security on Android, especially the fingerprint stuff and the new features since Android Marshmallow. And I think a few of you already have like an Android phone with a fingerprint sensor on its back and maybe want to know how to access it correctly and maybe how to secure the sensitive data with it. And so I'll just start with a short obligatory About Me slide. So yeah, that's me. I'm a computer science student from Germany. Currently, sitting there at 13,000 feet at the edge of a plane. And still studying computer science. And if I'm not like jumping out of planes, I'm a working student at Trivago, where we built like the Android app for a few million users out there. And in the end, mostly doing Android and Googlish stuff. So let's start. Cryptography. So why you should use cryptography? Cryptography is, on the one hand side, such a cool sounding word. On the other hand side, so many people get it wrong. And this is one of the points why I want to hold this talk, because there are many Android developers out there who doesn't really know how to like store sensitive user information, like passwords or email addresses or confidential user information on the device. And one of the top 10 security reasons in 2015 and 14 has been like broken or no cryptography inside the app. So if the cryptography is bad or not well implemented, it's maybe even worse than like to use no cryptography. So I want to ask the question: how can I, like as an Android developer, store my user-sensitive information securely in my app? So, luckily for you, there's the Android Keystore. But, well, what does it really do? Simple answer, it stores keys. But let's start at the beginning. In Android 1.6, there was like a credential store for VPN and Wi-Fi data, and it was accessible only by the settings menu. And it was able to store the public key infrastructure in companies and so on. Unfortunately, it wasn't accessible like by app developers or by a third-party app. Changed with Android 4.0, where it introduced the Keychain API. And this made possible to access the credential store. Unfortunately, all the keys which were stored in this credential store were system-wide, so every app was able to use it to access those keys. And those apps were able, or your app was able to fire some kind of intent in order to install a new certificate, and then this super beautiful dialogues popped up on the user screen. And as you can imagine, it's not the best user experience for the not so techy user to prompt and install like this certificate, to import it, to enter the password, and so on. So in Android 4.1, they finally introduced like the Keymaster HAL. It's more like a change under the hood. It's the hardware abstraction layer. And in 4.3, they finally introduced the Android Keystore JCI provider and the hardware-backed key storage, which is working in the trust execution environment or a secure environment on the device. And the Nexus 4 was the first device which really was able to, which had like this trusted environment enabled, and all the encryption was done in this secure part of this CPU or in a special chip. What's really awesome about that is that app private keys were now possible, and you could simply create your own cryptographic keys and use them to secure your passwords and your information or the user's data, and only your app was able to use them to encrypt, decrypt, verify, or sign. Unfortunately, the implementation in 4.3 was not that clear, because when the user changed, like the lock screen pattern or something like this, the data got invalidated and somehow it wasn't able to be used anymore, and there were some weird behaviors there, and so I think it never really worked in production that well. So they finally changed everything in Lollipop and Marshmallow, and again in Nougat. And that's what I want to talk about today. this will focus on the JCI provider and how to generate access to these app private keys. And later on, I want to show you how to use them or get access to them through like fingerprint authentication. So, has someone of you already played with the Keystore on Android? Not so many. So, yeah, okay. So, if you would have played with it, you may know the KeyGenParameterSpec, which is now deprecated since API level 23. And the KeyGenParameterSpec is used like to determine, to define the key parameters for the key, which gets created by the Keystore. And since like the JCI provider is not a new API like the keychain API was, in order to access like the system shared keys. Yeah, this is one of the major changes in these Android versions for US developers. So let's start. The KeyGenParameterSpec, yeah, implements an algorithm parameter spec. Yeah, for a key pair generator or key generator, and those key pair generators and key generators are just engine classes for finally creating those keys or certificates, and is used to determine the use of the key, like authorization, or if you want to decrypt or encrypt stuff, validity start and end dates, and so on. So basically everything you want to do, everything you need to specify the key. So let's have a look at a short example to generate a symmetric AES key. This works like the following. You have like the key generator, which is like initialized by .getInstance. And then with the key properties AES algorithm, key algorithm AES, and then the Android Keystore as a provider. After that, you initialize the KeyGenParameterSpec builder, which is there to build like the properties for the key, which is going to be created. And there you just define the name of the key, like in the shared preferences, and the purposes of the key, like if you want to encrypt or decrypt stuff. This is very important that you put everything you want to do, every cryptographic operation you want to do, that you define it here. Because if you want to encrypt or decrypt or verify something with the key later on, and you didn't verify it in this creation here, in this method, then the Keystore will reject to work with it. So after that, you have the builder and set all the parameters for your key, like the key size, block most, and encryption paddings. And finally, you just like say key generator init with the builder.build and key generator.generate key. And that's it. This is our key, which is created in the Keystore, which is only like accessible by your app and is saved in this secure environment. Let's have a short look how it looks like RSA. It's nearly the same. We just have like the key generator with the key properties RSA, the same Keystore JCA provider, have just a calendar and build like the key parameters with like a certificate and so on. And it's always possible like to add your own certificate or exchange the certificate later on, so you have your company certificate or whatever. And in the end, again, generator initialize, builder build, generator generate key pair in this case. So that's it. We successfully created my awesome secret key 01, and let's start encrypt something. This works like the same way. We just get an instance of the Keystore. Again, the Android Keystore provider. We have to call Keystore.load because this is somehow a relic of the old JCA API. If you don't do it, it will crash. So do it. And then we get our secret key by calling Keystore get key, my awesome secret key, null cipher get instance, and this is more or less, describes more or less the parameters we just built before with the build pattern. After that, we initialize our cipher in encrypt mode with the secret key. We have the encrypted bytes and say cipher do final. This is a super secret message. And after that, it's encrypted. To decrypt this whole thing, we just need to call cipher decrypt mode with the secret key, with the initialization vector, and finally get the result here. So it's basically a simple cryptography. What are the key advantages of the new Keystore? First of all, it is an OS-provided safe for all your key material and certificates, which is only accessible by your app. Another awesome thing is that it is hardware-backed on most devices. So even if your device is hacked or is tampered, then the keys are still secure because most of the processing takes place in this secure environment, which shouldn't be accessible that easy to the apps or to the user space. Since Android Marshmallow, all of this is reliable and very secure, so you can really use it in production to set up private keys. And they also improved the support for RSE, elliptic curves, AS and HMAC keys. So now, TrustZone here, TrustZone there, TrustZone everywhere. This is pretty awesome. 80 to 90% already of the devices already have this secure environment on board. So there's no need for expensive devices or something like this, because this trusted environment is also used to play digital rights protected media. And so it's available on most phones, and now it can be used to power this encryption stuff. And these keys which aren't held inside the trust zone cannot be exposed to the kernel, and that's a huge security plus there. And what's pretty awesome is that Android Nougat requires that. So every Android Nougat phone which is certified by Google will have a trusted environment or secure environment built in. And this is pretty awesome. So, and speaking of authentication, we all know that authentication is a very bad user experience. But fortunately, we're living in 2016, where Google is already inventing self-driving cars, gets the internet out to the rest of the millions of people out there, and finally makes authentication easier with fingerprint authentication. But let's start at the beginning. Authentication is annoying. It also is time-consuming and comes up way too often. So if you're developing an app which contains or works with sensitive user data and has or should have this authentication screen, it's really important to not bug the user in order that he wants to keep your app installed on the phone. What's pretty nasty is that almost 50% of all Android users do not have a lock screen, secure lock screen set up because of that, because they do not want to unlock the device every time when they pull out the device out of the pockets. But luckily, there's another solution for that. This is the set user authentication required to true, and the set user authentication validity duration seconds to 30 seconds or something more or less. And this is pretty cool because the Keystore provider integrates with the with your lock screen on your phone. So if you just authenticate it and you're going into an app and the authentication validity duration seconds is 30 seconds and the user is in less than 30 seconds wants to open your app can throw the authentication screen away and just display all the information while securing the data, which is pretty cool. Let's have a short look on how this works. We have the builder pattern I showed you before with the AES sample. You just add the set user authentication and the validity duration seconds there. And if the user isn't authenticated at that time, when you want to use the key, a user not authenticated exception is thrown. And then in this catch part, you can handle it and say, yeah, please authenticate, show a fingerprint dialog, or just an authentication screen, which is pretty cool because Android already has something like that built in. You can just get an intent from the key guard manager, which is create confirm device credential intent, and you can put like a title in a message in order please authenticate, and yeah, then just fire that intent, start that activity, and this will look like this. If you want to encrypt something and you're like haven't authenticated before, the system provided like authentication screen is shown, which is pretty convenient because if you have like features such as fingerprint authentication enabled, then the user could use the fingerprint or draw the pattern to unlock. So you're not bound to anything specific there. Yeah, and that's it. The sample IP is also available on GitHub. You can check it out. It's just like in one activity to keep everything simple. Yeah. And in on-activity result, you can just check if the user authenticated correctly and the result is okay. Then you just retry the encryption or decryption you wanted to do. And with that, yeah, you can just use the secret key. So in the end, authentication just got easier. You don't have to show like an authentication screen in your app. So this is pretty convenient if you're like sitting in the train and the user just is sitting in the train and wants to check his bank account balance or whatever, and he just unlocks his phone. This is the first like authentication screen, and then scrolls to your app, wants to open your app, and then again an authentication screen would be shown, and this part is now skippable. So the user just needs one authentication screen for the whole device, because with the validity duration seconds set to 30 seconds, you verify that the user is like still the device owner on the device. So yeah, and authentication just gets stronger, because authentication is now tied to the app secrets in the Keystore. The credential verification is like in the hardware, powered by the TrustZone. And fingerprint authentication is much more comfortable for the user, is easier, faster, has a consistent authentication flow when the user like opens your app and just sees a dialog, or it could also be like embedded into your activities, so just show the simple icon which Google provided you in order that the user knows, or to show the user that the app is able to be to authenticate via fingerprint. Also, the secure lock screen adoption on Nexus devices, when they first released like the Nexus imprint, so the fingerprint support on Android, went from 50% to over 90%, because the users really like authenticating with the fingerprint. They like the authentication flow. They like the idea of having like a secure app, because they have to authenticate, and yeah, they like to do it because it's somehow science fiction and something magic is happening there. And another cool thing is that smart lock reduces the screen prompts on devices without a fingerprint scanner or without like this hardware needed for it by 50%. So only every second time like an authentication screen is shown to the user, which greatly like improves like the user experience there while keeping the security aspect. So again, like have a look at this. This is the material design guideline for creating a fingerprint authentication dialog, and this should look like this when it's finished. Unfortunately, Google doesn't provide those fingerprint dialogues for you, so you can't just like fire an intent for that. You have to build it by yourself, and this is not the best solution, but it works. It's not so hard. I built one or more or less exactly the same in this example project. You can check it out, and you will see that's not so hard to get things done. So yeah, make it easy. Use fingerprints. What you'll need is a fingerprint reader, device running Android Marshmallow or later, and yeah, a user who is set up a secure lock screen and has enrolled at least a few fingerprints. But the last part is a bit optional, because you can always force the user to enroll one. And that works through the Fingerprint Manager. The Fingerprint Manager now organizes all the access to the fingerprint hardware and is like a system level service. It needs the normal permission, use fingerprint. What's a bit weird about that is that when you use it or declare this permission in the manifest and you want to access, like the Fingerprint Manager, Android Studio will say that you need to check for permission. But this is somehow a bug because Android Studio thinks that use fingerprint is like a security permission which needs like permission from the user, but it's not the case. Yeah, finally you get it by just getting the system service and the context Fingerprint Manager. And it has these two very convenient methods to check for device compatibility, like Fingerprint Manager as hardware detected, or Fingerprint Manager has enrolled fingerprints. And yeah, with that you can simply check if the user has enrolled some fingerprints or not, and then just show a dialog or whatever to say the user or to tell the user he should like unroll one if he wants to use the feature in your app. So yeah, and it's also available as a compat version. So if you want to develop like pre-Marshmallow, which obviously is the case, you will have to use the compat version, or you can use the compat version in order to have those methods, and they will just always return false on pre-Marshmallow. Okay, the Fingerprint Manager. The Fingerprint Manager has one important method. It's called .authenticate, and it takes a crypto object, which is basically a wrapper for a cipher or for a signature or something like this. A cancellation signal in order to cancel the fingerprint authentication process. Optional flags, but they should always be null or 0, sorry for that. And the authentication callback and a handler on which the authentication callback will be like called. So yeah, what I always told you, already told you is that the crypto object is just a wrapper class for the crypto objects supported by the Fingerprint Manager. As you can see, it only has like 3 public methods: get cipher, get MAC, or get signature. And the fingerprint authentication callback provides the following callback structure: on authentication succeeded with the result, authentication help, which shows you like, yeah, there's some dirt on the Fingerprint Manager or on the fingerprint sensor, so you can prompt the users to clean the sensor, or when the swiping was too fast. And the same applies for an authentication error. So they're more or less the same. The help is more to like swipe the finger more slowly or keep it longer in place, and the error would be called, I think, when when the sensor is too dirty or something like this. On authentication failed, yeah, is called when there's an error or an issue with the fingerprint hardware. So yeah, so this is what you should know as an Android developer, or implement the fallbacks for that. So yeah. Then there's the callback on authentication succeeded. How should we proceed with the crypto object? We simply get the crypto object from the results, like result get crypto object, and then we unwrap the cipher from with object.getCipher, and then you can work again with your MAC signature here to encrypt or decrypt stuff. This also works without like passing a crypto object to the Fingerprint Manager class. So you can just like open up the fingerprint dialog if you don't want to secure data or encrypt data. If you just want to have like a simple lock for your app, you can just set it to null and it will work, and it will notify you on the result if everything worked fine or not. So yeah, the best practices for a great user experience here: use the Keystore to check for user presence. So go ahead and try something new. Try to really like remove your authentication screen from the app if the user already authenticated earlier on the device, which is pretty cool. And if a fingerprint scanner is available, you should use that in order to, yeah, to test for the user presence there. And confirmed device credential intent is more or less the fallback, or for the lazy developers out here, which just want to use the system-powered lock screen with the pattern enabled and the fingerprint. Yeah, maybe I just add some another point here. You could like confirm or create your key in the builder with the authentication required. And if you set the authentication required to true in order to get like authentication for your key or certificate, and set the validity duration to 0 or something, yeah, less isn't possible, but to 0, then you will need to prompt the user every time he opens the app to use the fingerprint. And if you use something different, yeah, you can just like skip the authentication screen. So now a short demo time. As I told you, there is this app available. It's more or less a very basic app on GitHub, which features all of this different approaches, like creating a key without user authentication. Yeah, you could also use can also use like the Keystore to encrypt or decrypt stuff without like having the user to authenticate. You could also set like this authentication duration, or just use one for yeah, fingerprint authentication. And it's just like a sample app. And if you're interested in like integrating it into your app, then I would recommend it to you, yeah, to just have a look into it. I try to comment nearly every line of code, so it gets a bit easier to start with that. So yeah, that's more or less it. For further reading, I would recommend the developer pages and the source Android pages, which is quite interesting to read through it, because it's all the infos the device manufacturers get in order to implement those security features on Android. And another great book, which unfortunately only covers Android 4.4 and lower, is Android Security Internals. So for the people here who are really into security and want to have like a deep dive into the security system or how the security on under Android works, yeah, just check this one out. So yeah, thanks everyone. That's it. Feel free to add me on Google+, ask me questions. Yeah, thanks.
I have a question about the start of your presentation. Hi. I have a question about the start of your presentation about encryption, decryption part. Sorry. You was talking about that API comes with Android Marshmallow. And what about the previous version, low to KitKat? Is this available there, or? Yeah,
you have the Keystore provider also. It was introduced, as I said, in Android 4.3, but I wouldn't use it like prior to Android Lollipop, because it has this weird behaviors sometimes there, or I experienced some weird behaviors where the keys got invalidated or deleted. So yeah, I wouldn't recommend that. Yeah, since Lollipop, it's available there, and I would recommend to use it, but you don't have like the ability to create keys for like fingerprints, since there's no implementation or no API for fingerprint reading under Android Lollipop. Yeah.
There is no phones with Lollipop and
fingerprint readers. Yeah, I think there are. I think Samsung built ones, but it was their own fingerprint SDK they released. So I also got these questions from another guy someday, and he asked, "Yeah, what about the Samsung phone?" So yeah, this hasn't to do anything with the Samsung things. Yeah. The only thing you have to think about is when doing it on Lollipop that you don't have the KeyGenParameterSpec. You have to use the KeyGenParameterSpec, and this doesn't feature like the user authentication required and validity duration second stuff. But you could do it.
So you recommend not to encrypt the things before Lollipop, yeah?
Yeah, I personally wouldn't recommend it. Yeah, okay. But yeah, you could like just do. Check if you're like above Lollipop, then use like the Keystore. And if you don't have like this TrustZone environment on your devices, the Keystore falls back into a soft Keystore implementation, which is also really secure. So it's a really neat way in order to store your certificates or crypto keys.
Thank you very much.
Thank you.
Root issues.
Yeah, that's true.
I have a question about the situation when the user doesn't have a fingerprint and he didn't encrypt his device. What in such situation do I, as an app developer, have an opportunity to use those mechanisms?
Yeah, you're absolutely, you can use the Keystore. It will encrypt all the stuff with a generated or generic key it created, like I think depends on the device serial or something like this. So it still works. But if you're using like the Keystore and creating a key when the user didn't have like the device encryption enabled, and the user enables it afterwards, when you created the key, then your key gets invalidated. And this is the only point you have to manage as an app developer, to think of, yeah, if the user changed something like the secure screen, when you switched from like non-password to a password pin or pattern, then the key will get invalidated, and the other way around. So if he has like a secure screen and you create like your key in the app, and he switches from like authentication to no lock screen, then your keys will also get invalidated, and you will need to ask the user again for their passwords or whatever you want to store. But you will get like the exception Keystore invalidated or something like this.
Thanks.
Excuse me? No, it isn't. It isn't possible. So if the user changes like the lock screen, it's the same with, I don't know if you experienced it with your Android phone. If you set up a fingerprint in some app and then switch like from a lock screen to no lock screen, then the fingerprint thing wouldn't work anymore. So the app will tell you, yeah, please re-enable it, or yeah, we can't provide a fingerprint because like the security isn't, yeah, the security part isn't given there. Yeah.
Thanks for your presentation. I have two questions. One, will we find your GitHub under the same account as your Twitter name?
Yeah. It's
okay,
the
great.
same.
And second, what if I explicitly launch an intent to start the system lock screen, but user has no lock screen defined?
Yeah, then it will. That's a good question. I haven't looked into that, but what I did was in my code I checked if the confirmed credential intent is null. So if it's null, yeah, then the user apparently has no. I think if it's null, then the user has no lock screen enabled, or when you start the intent, it will immediately return like the user has authenticated on the screen. I think it will be either one of them. So, but I can't say 100%.
The situation when you are installing certificates, it will always, because if you are installing the custom certificate on the device, it is required for you to have lock screen.
Yeah, exactly. This has to do with like the Keystore service as such, to increase like the security there.
Okay, I have one question.
Yeah.
If you can show the screen with the yeah, if you could show the screen with the callbacks for
the fingerprint.
Yep.
Yeah.
Oh, okay. So which callback will be called if the user will not succeed with the recognition of his fingerprints?
Yeah, that's a good question. I think it's like on authentication error or authentication failed, but it should be on authentication error. But you get there's the whole documentation out there, but I don't have it like in my mind right now. But you can just look it up, like the error code, and they have like for every scenario they have like a different error code, and you can just simply check it and then display.
Thank you. Thank you.
Have you checked this solution with some kind of hardware to check fingerprints, not embedded to the device?
Excuse me, what do you mean?
Do you check this solution, for example, with hardware devices plugged into the Android device?
If you mean if there's like an accessory, like a fingerprint reader is plugged into USB, actually, I don't think that this works because I think that the device manufacturer has to provide like the implementation of this, fingerprint reader part. So I just think this will work with the integrated fingerprint reader. Maybe just because of also security reasons. So someone could just plug in a new a fingerprint reader.
I thought that some Android accessories has the certificate that they are Android accessories, and you can use.
Yeah, this might be, but I think they should have like their own SDK or something like this, because as this fingerprint service works, it never exposes like the fingerprint data. It just says, yeah, fingerprint with ID like 1 or 2 or whatever has successfully like was recognized, and this is like very internal. So I don't think that a third-party device is able to like integrate into this service. So I
think it's also a matter of drivers for this.
Yeah, exactly.